Hello everyone and welcome to another video with Special Maths Academy. In this video, we'll be looking at the ninth problem from the Special Maths Contest 2024, the first round. And it says, ABC in base 10 is a number with distinct non-zero digits. So we have to pay attention to this. Okay. The digits of this number are rearranged such that no digit maintains its original position. So we're already told that there are two possible permutations satisfying this. What's the maximum possible difference of the two numbers formed by this permutation? Okay. So if we have, let's look at the ways that we can rearrange this such that no number ends up in the same position. So first of all, we can have something like this: C, A, B. Okay. So here we can confirm that C is not in the third position, A is not in the first position, and B is not in the second position. And then another possibility we have is BCA. Okay. So the next thing we want to look at is the difference. Okay, so let's look at the difference of these two numbers. So CAB is basically 100C plus 10A plus B, and then BCA, so is 100B plus 10C plus A. Okay, so if you find the difference, so let's look at the difference between these two. So 100C minus 10C, that would be 90C. Okay, 10A minus A, that would be plus 9A. And then B minus 100B is going to be minus 99B. Okay, so let's look at this. So I can put it in absolute value terms because we don't really care about the sign. We just want to look at the largest possible difference. Okay. So we can factor out 9 to make our life easier. So this becomes 9 to 10C plus A minus 11B. Okay. So now don't forget that we're dealing with uh, distinct integers. Okay. So there's something called rearrangement uh, inequalities. Okay, so we can try to use that idea here. So, okay, so there are basically two possible values. So we can look for the largest possible value of this, and then we can also look for the largest possible value of this. So 11B minus 10C minus A. Okay, so in the first case, we have the coefficients in this form, 10, 1, and minus 11. Okay, so what does it tell us? So rearrangement inequality, if you have two sequences, so let me just put something like if you have X, Y, Z, and you have A, B, C. Okay, so if we order it, then if you take them in pairs and you multiply them, rearrangement inequality tells us that if you want to maximize this, you want to, this is the maximum possible value you can get. So then I'm just stating a special case of rearrangement inequality. So this is greater than any other way you can pair it. So for instance, if you say XC plus YB plus ZA, so it's greater than any other possibility. So for those of you who are interested, you can read about rearrangement inequality. Okay. So we can see that 10, 1, and minus 11. So we have 10 is greater than 1, 1 is greater than minus 11. So it means we need C to be greater than A to be greater than B. Okay. So that's the first thing. So now, of course, if we want to maximize this, the bigger the value of C, the bigger the value of this whole term, this here. So basically, as C increases, this term here increases. So I'm looking at the first case. Okay, so as C increases, this term increases. As A increases, this term increases. As B increases, this whole term this whole expression rather decreases. Okay, so I have to take note of that. Okay, so it means to maximize this, first of all, C has to be the biggest. Okay, and then as C increases, the whole expression increases. So it means uh the value of C that maximizes this is going to be 9. As A increases, the whole expression increases. But recall that we're dealing with distinct uh integers, digits. So A has to be 8. Okay. And remember, as B increases, the whole expression decreases. So we want to start looking for the smallest possible value of B. Okay. So B has to be 1. And in this scenario, what do we have? We have 9. So let's look at it. So 10 times 9 plus 8 minus 11 times 1. Okay, so this is 90 plus 8, so 98 minus 11, which is equals to 87. Okay, so this is the maximum possible value of this. Now, if you look at the second expression, so as before, we have 11 is greater than negative 10. Okay, I think I should arrange this in this way. So let's put it this way. 11b minus a minus 10c. Okay, so 11 is greater than negative 1, greater than negative 10. Okay, so it means by rearrangement inequality, we need, b greater than a, greater than c. Okay, so now to get the value of b that maximizes this. So, okay, first of all, let's look at each of the expression. As b increases, the value of the whole expression increases. As a increases, value of the whole expression reduces. As c increases, the value of the whole expression reduces. Okay, so we maximize b. Okay, then uh, we know that a has to be greater than c, and we know that as c increases, the whole expression reduces. So c has to be 1, and then a has to be 2. Okay, so in this scenario, we have this expression becomes 99 minus 2 minus 10. Okay, and 99 minus 12 becomes 87. Okay, so we have that in both cases. 87 is the value that's the maximum possible value. Okay, so it means so the maximum possible difference is going to be 9 times 87. Okay, so remember that we factored out 9. So it's 9 times 87, which is equals to 783. Okay, so 783 is our answer. Okay, so quite an interesting question. So it means there are two possible numbers that satisfy this. So okay, let's see. So let's look at the numbers that satisfy this. So we have this one here gives us 819. Okay, so 819, and then this one here gives us 291. Okay, so we have this 291 and 819. Okay, so these are the numbers that when you carry out this operation on them, then they give us the maximum possible value. Okay, that satisfy the condition in the problem. So um, that'll be all for this video. I hope you enjoyed the video. Please don't forget to share, like, comment, and subscribe. And stay tuned for more videos in the future. Goodbye, everyone. Have a nice day.